Well, we're back again. Here we are. And we are on Module 4, Lesson 8, Percent Error Problems. All right? The essential question, how do you find the percent error? And I know that sounds kind of weird to talk about, so let me kind of explain this, give you a little background here. So my dad used to actually help make parts for cars, right? And when he was making it, he would be told he could be off by a little bit, right? Because if a little bit of the car part is wrong and a little bit of the car part that goes next to it are off, you eventually you need everything to be like 100%, or it can't be 100% perfect, but you need it to be really close, or otherwise the car's not going to work, right? So we need to know about this percent error. And my dad, his whole job was based on making sure that that percent error was really small. And we're talking really small. Okay, so let's take a look at this here. So we have 3 students, Connor, Taylor, and Jordan, and they're measuring, right? They're measuring a computer. Okay, and they're measuring the length of the computer across the diagonal. And so they take their measure tape and they measure it, and these are the different measurements that they have. Just so you know, the computer monitor is actual, or the exact, right? It tells me that it was a 15-inch monitor, right? 15-inch monitor. By the way, monitors are measured across the diagonal from the top down to the bottom. Okay, so let's figure out just how far off these 2 kids are. Well, in order for me to, or 3 kids, in order for me to do that, I need to know a couple things. So what we're going to do is we're going to take the exact that I gave you, and we're going to subtract the approximate, or the student's measurement, because the student didn't measure it exactly. I mean, if I had you guys do it, you wouldn't get it exact either. I don't even think I could. Okay, the exact minus the approximate, or you could say the approximate, right? The approximate minus the exact. You could do it either way. You're going to get the same answer, okay? So, but by switching the order that I do it in, I'm going to get a positive or a negative answer. So in order to avoid that, I'm going to use the absolute value, because the absolute value just turns your answer into positive. So I'm going to say the approximate, A, right? We'll call that A. Minus the exact. I'm going to use X for exact, okay? We'll just use the letter X for exact. Okay, so then we can kind of plug them into these little formulas. So Taylor's measurement 1 for Taylor was 15 2/8, right? Because those little measurements are all in eighths. So she measured it, so I'm going to take the her answer of 15 2/8, and I'm going to subtract the exact, which we know was 15. And when I do that, I get the absolute value of 2/8, which is also known as 1/4. So in other words, she was off by 0.25, or 1/4 of an inch. That's not too bad. All right, let's try Connor's. Connor's, his first measurement was 15 1/2, but we know the exact was actually 15. So when I subtract those, get the absolute value of 1/2, or just plain old 1/2 of an inch, or 0.5 of an inch, however you want to think of that. Okay, well, let's take a look at Jordan's measurement 2, not the first one, but the second one. All right, second measurement for Jordan was 14 6/8, and we're going to subtract the actual, which is 15, and so the absolute value ends up being negative 2/8. Well, absolute value of a negative number becomes positive, and if I change 2/8, it just becomes positive 1/4. Jordan was off by 0.25, or 1/4 of an inch. Okay, and that's basically how we're going to work with these. Okay, now we're going to change it, because of course this book is all about percent, and so let's talk about this and changing it and how far off we are. So we're going to find the percent error. Now we're going to find percent error. In order to find the percent error, you are going to use another formula. You're going to take the, make sure I have my notes right. We're going to take the approximate minus the exact, just like we did a second ago, and we're going to put it over the exact. Okay, that's all we're going to do. We're just going to plug it into that formula and we should be able to find these. So let's find the percent error for Taylor's measurement 1. Well, okay, I'm just going to go through the process kind of a long way the first time and then we'll shorten it up. So the absolute value of 15 2/8 minus the 15, which was the exact, all over the exact. Okay, well, we already know that that answer of that, we got it on the other page there, was 0.25 over 15. We grab our handy dandy calculator, we divide this, and then, oh, hang on one second here. We're going to divide that and then multiply by 100 just so it changes it over to a percent for us. Okay, or you can just divide it and then move the decimal point over, but I'm going to end up with 1.6 repeating percent, or 1 2/3%. Okay, so she was really pretty close, right? Her error wasn't too far off. Well, let's try the same thing with Connor's measurement. Now again, we already have the measurement done. We did the math already on the other page. So if you want, we're just going to grab that answer from the other page, 0.5, and we're going to divide by the 15. Okay, oh, I keep making this mistake, times 100. I'm just not used to doing that. Times 100, and I get an answer of 1 2/3% again, right? Okay, and something's not right here. I gotta fix this. Okay, I figured it out. I typed something wrong on my calculator. So this ends up being 3 1/3%. I apologize for that, you guys. Okay, letter F. We're going to again get a hold of the information from the other page in which we are talking about Jordan's measurement 2. Jordan was off by 0.25. Granted, she was too small, but it doesn't matter. And divide that by 15, multiply by 100, and we get 1 2/3%. Okay? All right. So finding the percent error tells you how big your error is compared to the true value. Okay? That's kind of important to know. It's going to help us. It tells you how big your error is. How big the error is compared to the true value. Compared to the true value. And obviously you want that number to be really, really, really small. You want to be as close to that true value as you can. You don't want that to be big, right? All right. Let's take a look at what's going on here for exercise 1. I actually would like you guys to hit pause and give this one a shot. See if you guys can figure this one out on your own. When you're done with number 1, go ahead and hit play. All right, so 18 people showed up for an open house, or expected 18 to show up, but actually 25 did. So the expected was 18, the actual was 25. So the absolute value of 18 minus 25 all over the actual, which was 25. So the absolute value of -7 over 25 is what I get. So it becomes 7 over 25 because I'm just going to take the absolute value, make it all positive, multiply it by 100, and I get 28%. So the realtor had 28% error on her or his guess as to how many people were going to show up. All right, page 67. In science class, Mrs. Moore's students were directed to weigh 300-gram mass on a balance scale. Tina weighed the object and reported it was 328 grams. All right, I want you guys to figure out how far off Tina was. So again, hit pause and see if you can figure this one out. Okay, so the student reported, Tina reported that it was 328, but it really was 300. So 328 minus 300 gives you a 28, and the exact, or the exact, excuse me, was 300. So when I divide that and then multiply my answer by 100, I get 9 1/3%. Let's take a look at number 3. Darwin's coach recorded that he had bowled a 250 out of 300 in a bowling tournament, right? 300 is a perfect score. The official scoreboard board showed that Darwin actually bowled a 225 out of 300. Okay, so the 300 actually isn't part of the information. It's extra that we don't need. We need the 250 and the 225. Again, I want you to hit pause. See if you can figure this one out. All right, so I took the absolute value of 250 minus 225 and put it over 225. Found that. Ended up with 25 over 225 multiplied by 100, and I get 11.1% error. Okay, believe it or not a fan. Don't really like to do example 3. Don't need to do example 3 because guess what we're going to do? I know you guys get great satisfaction out of this. We're going to skip example 3. And if you look, that is all she wrote, folks. We will talk about the summary when you come back to class. See you all later.